Throughout my childhood, I had always seen this one equation, whether it was on a poster in my kindergarten science classroom or featured in my favorite TV show. After constantly seeing it growing up and not knowing much about it, E equals mc squared made a permanent mark inside my brain as the single equation that explained modern science. Although I was not exactly right about this, after having researched it and its origin as well as the theory behind it, I wasn't that far off. This single famous equation, known by nearly everyone who has ever taken a science course, might be the most important realization made in theoretical physics. I'm here to explain the theory behind it and how it came to be realized. To fully understand this equation, you need to know the theory behind it. Special relativity is one of the most important and, in my opinion, fascinating theories ever created in theoretical physics. It was formed on September 26, 1905, by Nobel Prize winning physicist Albert Einstein in a paper titled On the Electrodynamics of Moving Bodies. The formation of this theory was a result of a large number of factors, mainly being the discrepancies between Isaac Newton's three laws of motion and James Clerk Maxwell's equations of electromagnetism. To break it down into simple terms, Isaac Newton's three laws of motion basically stated that an object's speed is relative to the things around it. For example, a train going 40 miles per hour with respect to someone at rest is only moving 20 miles per hour with respect to another train moving 20 miles per hour. You can kind of think of this like subtraction. The difference between the speed of the object moving faster and the speed of the object moving slower is equal to the speed of the object moving faster with respect to the slower moving object. In contrast with this, James Clerk Maxwell stated through his famous equations regarding electromagnetism that the speed of light is constant, thus defying Newton's laws of motion. Because of this discrepancy, Einstein chose to investigate how objects move through space and would thus form his theory of special relativity, and within it would be the equation E equals mc squared. When forming his theory of special relativity, along with other theories Einstein formed later on, he loved to incorporate little thought experiments into his research. These thought experiments allow slightly less brilliant people, such as you and me, to get a better understanding of theoretical physics. And so, one day Einstein rode a tramcar back to his house after a long day of work and made a pivotal realization. As he moved away from the Zeitgloggy clock tower, Einstein imagined what would happen if he were traveling away from the clock tower at the speed of light. After thinking about this, he concluded that the hands on the clock would appear to freeze, and thus time would slow down. He also knew that the clock would be moving at a normal rate to the people outside of the tramcar. This thought experiment led to the idea of what Einstein called time dilation, which contains the basic principles of special relativity. And from all this, Einstein concluded that the faster an object moves through space, the slower it moves through time. To truly understand how Einstein formed his famous equation E equals mc squared, you really need pictures to help you visualize what it actually explains. In this instance, I want you to imagine a cat floating in space that suddenly emits a large flash of light, which carries away some energy, but also gains the same amount because the light was flashed in all directions. Because of this, the cat's velocity stays the same. Now, we don't know where the energy came from, but we don't have to worry about that yet. Instead, I want you to imagine that you're in a rocket ship flying in space away from the cat. From your new perspective, you see the cat whizzing past you, and thus you have to give it some kinetic energy. And because it's the same experiment, but in a different perspective, you see the same flash that we talked about before, and so you subtract that energy from the cat's kinetic energy. However, because the rocket ship is moving at the speed of light and the cat is stationary, time dilation tells us that they are experiencing time at different rates, and thus the frequency of light would be different, and same with the energy. This leads into the Doppler effect, which states that we have to multiply our energy by 1 plus the velocity squared over 2 times the speed of light squared. So going back, when you are in the rocket ship, you give the cat kinetic energy, but take away energy times 1 plus the velocity squared over 2 times the speed of light squared. However, if you wait for the cat to emit light, you are only subtracting the energy by itself. And with this, you still add kinetic energy. But because you never interact with the cat, these two amounts are the same, so you can set them up to be equivalent. And so after rearranging, we can see that the kinetic energies are different before and after. And kinetic energy is equal to 1/2 times mass times velocity squared. And we know that the velocities stay the same, so the mass has to make up for the difference. And after canceling everything out, we get that the change in mass is equal to energy over acceleration squared, or E equals mc squared. And so, in conclusion, special relativity, a theory created by famous theoretical physicist Albert Einstein, was a pivotal step in the process of furthering our understanding of how objects move through space. He couldn't have formed his theory without groundwork already laid out by Sir Isaac Newton and James Clerk Maxwell. And time dilation, the main component of his theory, can be considered the first step to time travel. Thank you.